And last thing I was working on. I want to make sure that I remember to mini lesson. Yes. Okay, so yeah, module 3, you got lab 2, quiz 3, super straightforward this week. For lab 2, you're really jumping into classes and stuff. Yeah, you're really jumping into classes. So of course you've worked with classes in programming 1, but you've never, like, C++ classes are very similar to programming 1 classes. Just now that it's a new language, that can really hit some hiccups. So we want to make sure that you can understand any sort of syntactical difference between Java and C++ by doing this lab. The only real differences would be the vector, not really even strings. You worked with that last time. I think that's probably just from this lab used to be earlier in the semester. But definitely vectors, definitely the big three. The big three are the copy constructor, assignment operator, and destructors. So just going through this lab, you're going to need those things. And that might not have been something you dealt with in programming 1. I don't think it is at all. But then while you're doing this lab, it's really important to just read through the entire thing first. And then once you're done reading through it, understand that you should be able to just copy and paste the required functions from here. So we tell you that you're going to need to have these functions. And these are the function prototypes. Remember last time we talked about prototypes where they give you the return type, the function name, and all the parameters. They just don't have the actual implementation. That's what these are for. That's the whole point, is that we're giving these to you so you can just copy and paste them into your code. And you're going to need these functions with these exact prototypes. So I sometimes when we talk about programming, we tell you not to just copy and paste stuff. But here I'm telling you, yes, please copy and paste stuff, because since it has to be the exact same, you need to make sure that you are getting the right name. So if it's not named right, you might run into some errors and get confused by that. So probably could have done that ahead of time, but that's fine. In here, I might just like copy and paste some of this stuff just to talk about it. But some of the things I just want to show you the uses for vectors. I think we talked about this last time. If I just Google vectors C++, the first thing that pops up is this website, c++.com. I highly recommend going here and looking at some stuff, but I'm going to point out some really important functions and just show you how to use it. Size, that tells you the size of the vector. So if it's currently storing 3 elements, that'll return 3. And then pushback, that's the other really important, that's the big one. So a lot of times when you're working with arrays, you really just want to add elements to the end of it, or just repeatedly add elements to the end of it to make it bigger. That's what pushback is for. Don't try to initialize a vector with a current size. You can do that if you resize it. There are ways to use resize, and then you could just use the square bracket operators to access elements. That would be how you do it in Java with arrays. But I highly recommend using pushback, because in my experience, people really understand pushback once they start to use it. But again, you can always try the resize and square bracket operators. But once you use pushback, then you can use the square bracket operator to get access to certain elements, just like you would an array. So hop into here, close all of that, lab 2, let's create a main. Main CPP, there we go. And then let's add one class. And we'll make it the vehicle class, so we'll talk about that. Vehicle HCPP, cool. It's gonna make the class great. Got a basic little class set up there with a header file and its appropriate CPP file with the includes all done. And then in main, we'll also make sure to hashtag include vehicle.h. There we go. Okay, so just using vectors, straightforward. I'm going to do like a basic for loop with vectors. So your vectors aren't natively in C++. You have to include them. So just go to any one of these examples. I'm going to go to the pushback example since that's what I'm about to use right now. The example right here, the include for is just hashtag include vector. You might get the pattern with like strings and stuff that some of the includes are really, they say what they include. They're not trying to trick you there. IOStream, if you didn't know that IO stands for input output, that might be a little weirder, but straightforward still. Using namespace, I can spell std. Always include that. I always include that. You technically don't. You could manually put the std in front of whatever you want. And I can't actually see what I'm typing. There we go. Semicolon. So now we have access to vectors. And when you're initializing a vector, they even show it right here. You put the type of vector inside these triangular brackets. So in this case, I will just make an int vector since I'm trying to show off an integer. But you could also make a vehicle vector. You can make a vector of whatever object you want to. Don't be scared to do any sort of object inside a vector. The only thing is once you do it, you have to be consistent. So I'm going to make an int vector, and I'm going to call it vec. And here, this is not a primitive data type. So this does have a default constructor, so you don't need to initialize it to anything. Technically, the way you could hard initialize it to the default vector would be to just do vector int braces. Like you can do that. I sometimes do that just because I've worked in so many languages, I forget what is defaultly initialized and what isn't. But that's totally up to you. This functionality should be the same as if you didn't have one because it does defaultly construct that object. Okay, so then to use it with like say a basic for loop, so I equals 0, I is less than 10, I plus I. And so from here we can do vec dot pushback, and pushback's function, and we just pass in I. And so here, this is going to be adding I to the end of this vector 10 times. So it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then to print it out, it's just a super straightforward in reverse. Int I equals 0. And instead of doing int I equals 10, since that would be more hard codey, int I less than 10, we could do I is less than vec dot size, because it does have a size of 10. And then plus I. And here we can do cout. I didn't include IOStream. Another super standard one, even though I talked about it, I'm surprised they include it. Cout vec square brackets I and line. So it's just a new line every time. So this hopefully makes sense to you what I just did, but I'm just showing you that you don't need to do, if we did, you can't just do this. So this is an error. If we did vec.resize, resize 10, then it shouldn't be, oh, there's a dot there. There, so this should work. So if we run this, oh, I'm running the wrong project, woohoo. So this is startup. Oh, it printed a bunch of zeros. Why did it print a bunch of zeros? I equals 0. What? Let me redo it to what I had before, make sure that works, because this is what I want to tell you works. Yeah, okay, this should work. The other one, we can figure out why that didn't work in a little bit. There you go. So this one printed out the 0 through 9. So like I said before, even maybe I don't understand exactly how to do it properly the other way. But this way makes sense to me at least. And so maybe I'm very biased, but I've definitely seen a lot of people use it. So hopefully it's pretty straightforward. But using pushback, it just adds it to the end, and then using a for loop like this, you just do I through the size, it will get through everything, and that's what most people need. So I recommend using vectors a lot like this. Any questions about vectors? Okay. Cool. Next to vector strings. I'm not going to go over strings. We talked a lot about that last lab. I think they talked about strings in here just because this used to be an earlier lab. So I'm not going to do that. I will go into classes now. Let's talk about classes. Classes. We've got the H and the CPPs. We did talk about this last time a little, didn't we? I'm making some weird. Oh yes, because that's for the quiz. Yes, the quizzes are before the lab that includes what the quizzes are about. Though this week's is, I think, since we talk about copy constructors and stuff, let me look at what do we got? Do we have any pointers in these things? I don't see any pointers. I don't think we need constructor. Yeah, I don't know why it talked about the copy constructor and stuff. Yeah, we're not using that in here. Okay, so we'll talk about that maybe next week. We'll see. I can still discuss it. I can still discuss it, but outside of the context of pointers, that's fine. But okay, anyways, to start off for this lab specifically, with classes, you really should. So this is the vehicle class. I'm going to copy the stuff that's all under vehicle header. So like this vehicle and all of this is vehicle information. All of this. So up until showroom, you can just copy this stuff. Let me select. Oh, that's not words. Wow, that's so rude. It's a picture. Why? Okay. Well, then you can't just copy and paste it, which is really sad. That's oh my god. I think we used to be able to. Maybe they removed that, so you have to type it out. Okay. So you can just straight up type it out then. Vehicle default constructor vehicle string make string model int year float price int mileage whole shebang. I did not, so even though I included it in the other file, I didn't even include strings in this file, but I need to put all of that stuff at the top of this one. So hashtag include string using namespace. It can get a little redundant. I can understand that criticism. STD. There you go. String. Let's see if this is all good. Yeah. Okay. Cool. And void display. String get year make model float get price. So these, like I said, you need to have these because when you submit to Zybooks, I'm fairly certain the main is already created, and the main calls certain functions. So since it's calling those functions, you need to have it because I don't think you can change main. I think that's a big no-no. It's oh my god, I don't even know where the mistype is, but this doesn't look like a real word. It does not look like a word. No one uses the word vehicle in a sentence. They just say a car. I know it's spelled right, but it doesn't look right. because you only talk about vehicle, you never write it. Because they want to showcase non-cars in the showcase, Anna, Gabby. You're limiting your showcases. We gotta make the company happy. Okay. Here's the lab. I hate everything. Lab 2. Oh, and lab 2 separated into like 3 parts. I remember that. Oh god. Is this? Oh yeah. So main is given to you and you can't change. I'm gonna load default templates. So yeah, this is main, and you're not allowed to change. I might be allowed to change this because oh, I can change it. Maybe you can. Oh no, you're definitely changing it. 'Cause you have to do the to-dos. Oh well, don't change any of the other stuff. Don't change the other stuff. Even though you can, don't. You need to just change the to-dos. It looks like you only have access to the vehicle IH and CVP now, so that's cool. So yeah, you shouldn't change anything that's already there for you. Only change what's in the to-dos in the main. But so yeah, once you're given the vehicles, then they tell you what the vehicles will do here. So the constructor and vehicle itself, it's telling you these things. That also help. Oh, and then it tells you what's in the vehicle class is base container. You'll need to store the following as private data members, and then the rest are public functions. So let's make sure we do that as well. So public, private. And again, you don't need to explicitly say private in a class because the default will be private. So if you put it at the top, it's fine. But I'd like to be explicit. You got a string to store the make, a string to store the model, unsigned integer to store the year, unsigned int year. A float, store the price, and then an unsigned int. I didn't spell signed properly. Unsigned int to store the number of miles. So one thing to note is that all of the things that I named them up here are the same on, oh God, I missed, there you go. What I named them up here is different than what I named them down in here. Not different, they're the same, that's, yeah, big. Okay, so I did make, model, year, price, mileage, so even this one I might change to mileage. Sure, just to showcase this. What they're called inside of here isn't affected, like the main doesn't care because these are private stuff. And this doesn't care what the parameters are called inside. It just has to put them in you have to make sure you put them in the right order. That's the big thing. So one thing some coders do is like a little trick is they put underscores next to the one in the parameters because theoretically you're only using the stuff in the parameters once when the function's called, but the other things might be used a lot more. So to differentiate between them, you just put a little underscore there. You can also, we're going to get into like this object. To differentiate between the two of them if you kept them as the same name, because there's a reason why this isn't a compiler error. You are allowed to do this because inside the scope of this constructor, make would be just make, but then the make from the parameters would be just make, but then the private variable make would be this dash arrow make, if that makes sense. So differentiating between what's parameter and what's a member variable using this object, which is the invoking object. So if you remember that from last lesson, you can have them be the same. But as I prefer to avoid having to explicitly say this keyword unless I need to, I'm just going to put dash. Maybe I'll do it real quick. I won't do it for make. So I can make the make sense joke again. But so from here, just I'm going to have it automatically make the signature because I can cheat because we're using an IDE. And so for model, year, and price, it'll all be the same. So I'll just do one for model. So model equals model underscore. So that's legal right here. And this is the this keywords model. And then this is the parameter model. And you can kind of see the difference because if you hover over this one, does it, if I zoom in, yeah, okay, yeah. It doesn't zoom in the hover over information. But you'll see here, this is standard string in vehicle model. So that string is the vehicle model string. But this underscore one is just standard string. There's no vehicle : : So that's how you can see that it's referencing the this objects. If we did this, and now if we hovered over it, that's how it differentiates between the two. You can like get a little tell there just to confirm. But then, oh yeah, then for make, we couldn't do that. So see here, this is still legal. You are allowed to write this. Again, C++ allows you to do a lot of things. Like you can just do this. It's not even a warning. But if you hover over them, this is standard string make. There's also standard string make. So these are all the same strings. Well, this is, so if you see the hover, like this is me clicking it now to highlight in blue. You can see that it's highlighting both. And so to make the differentiation, you do this, Periscope make. I spent way more time on that than I really needed to. Okay. So with that, I assume that you can do the vehicle constructor, that's the default constructor. And it's gonna need these values. So you set it, you manually set it to those values. We give it to you right there. Get make year model, it returns a string in the form of year make model. So you literally, so this is like an example right there. So you'll have to do that. You'll combine year, make, and model, and see that year is in an int. So you'll have to convert that int to a string. We talked about, we had string to int before, but now I got int to string. I think you can just add it together, but you'll have to figure that one out. And then get price, just that's a getter. That's a accessor. We talked about that last time. Showroom. Again, here's some things. This is the default constructor, and look, it's got those string name equals unnamed room and unsigned capacity equals 0. So that's a default constructor, even though it's got all those default values in it. So technically, you could do the same thing with vehicle, but we want you to write two separate ones. So we just want you to explore the differences. So there's constructor. Get vehicle list. Even though this is returning a vector, it's still just a super basic accessor. I've seen some people overthink get vehicle list. It's just an accessor. It's just a single, you're returning that vector. Add vehicle, you're adding to the vector. So we talked about adding to vectors with that little for loop setup we had. So don't overthink vectors is going to be my biggest thing. So you're just adding to the vector. Show inventory, that one is like you'll call the display function in each vehicle. So that prints out the 1973 Ford Mustang and then its number value and then its mileage. So that's just printing out that information and it's calling that for each vehicle. I think there might be some extra stuff, like if we hit submit right now, this doesn't actually have showroom, does it? It's gonna be the next one. Oh, it doesn't compile. That's so funny. It's gonna make me cry. Okay, when you actually get something that can be submitted and you do submit, when you finally hit the submit button, this isn't gonna work. But when you do hit that, you can use Zybooks to see when it's like show inventory, when show inventory is right here. So find the submission that has the input 3 for test num and see what it's printing out. So it's probably a little more information than just calling the display function for each vehicle. Oh, and it might even be right here or something. Oh no, probably not. Oh yeah, it's probably gonna be vehicles, and so you have to say like vehicles in something or whatever. But so yeah, if you're confused about if it show inventory like exactly what it does, just do what it says here. So just call the display function on each. No, here we go. Call the display function on each vehicle and do it in like a new line or something. But at the end, like finally just get it compilable, submit it, and Zybooks will tell you what it needs to actually do. Cool. Get inventory value, sum up all the prices. So that one, some students have an issue with, like, how do you sum up all of the values? Just go through the whole vector and just add all the prices together. Oh, the sum, the get average price in dealership. That's the weird one. So the get average price in dealership, you have to get the vector from each of the showrooms, because a dealership is a bunch of showrooms. A showroom is a bunch of vehicles. So it's that 2 layers of for loop. And you can use a separate variable to keep track of the number of cars as you go through the entire thing. And that's definitely one of the challenges of this assignment. I know the whole thing is classes, so setting up the classes is important and is a challenge. But I've seen a lot of people struggle once they get all the classes set up and they get through that hurdle, that specific one. So make sure you that one you definitely need to think about. So it's not, don't overthink it, but don't limit yourself don't limit yourself to not making some spaghetti code for it, because there's not like a simple one size fits all answer to it. There's not like it's just this function, it's super easy. It's a whole thing that you have to think through, like, how do you get information? And once you realize how to get the information, don't try to make it look pretty, just get it. Same thing with show inventory as there was for show inventory here. So for both show inventories, just don't worry about the exact syntax. Just get it compilable and get it printing out something. So this one calls the show inventory for all of its showrooms. So just make sure you do that at one point, and then once you actually get to Zybooks and submit it, you'll be able to see what it wants for exactly what it wants printed out. Printing out tab characters /T, that's like that's an escape character. You had that in Java too. Work through it one at a time, and that's why it's separated into like part 1, part 2, part 3. So just start with part 1, get that fully working. Go to part 2, get that fully working. Go to part 3. And then work on one thing at a time. That's fine. So while it says work on one thing at a time, I do highly recommend getting it all set up first. So in here, like with what we have here, in Visual Studio, it's really easy. You can just do, so like once you've written out all of the prototypes, you can just, stop it. You can just click create definition and it'll create the definitions. Stop show potential create definition. Show potential fixtures, create definition. So once we've got this, you could, I think here, I muted myself when I was trying to click things. I'll do it right here, where then once I created all the definitions and stuff, I'm just gonna go, we're in like part 1. Main's all made for you, but vehicle.h, I will copy over all of my vehicle.h, and then vehicle.cpp, I will copy over all of my vehicle.cpp. Yes, so if we now, this should actually submit. Yeah, so I'd highly recommend getting that set up just to make something submittable. And then you can see here like what the expected output for things are. And so of course this is 0 points, but it's still really useful just to see what each of them do if you want a visual for that. Though for just part 1, this isn't really useful, because I think the vehicle class, we give you all that you need to know, and we even give you like examples No, we just give you all that you really like, an example here or something. So we give you all you need to know for it, but maybe the future ones, I think there's some extra stuff you need to print out we don't talk about. Okay, I think that's all for lab 2. Did I put anything down? Yeah, we're not getting into the big 3. That's not, it talks about at the beginning, but we're not getting into that. That's for a later day. And then we talked about using the instructions. Yes. Cool. Any questions about the lab? Okay. Now on to the quiz. You guys, my understanding, you've talked about pointers in Fox's class. Yes? Maybe, hopefully, you don't have to have understood them, but you did talk about it. Oh, Eric, do the definitions go in the H file, the CPP file? Like we talked about last time, the way that it's supposed to be set up is that the H file just has the prototypes and the member variables, because this is now really easy to read and understand what's going on. Maybe you want to put a comment or something about what's the stuff, but this should be easily scannable. And then in your CPP file, that's where you actually put the definitions, because these algorithms are usually not as easily readable. And that the reasoning I gave you is because like the readability, but then that also helps for like in a bigger project compilation time, because if you change the CPP file, that doesn't change the vehicle.h and doesn't change the main.cpp. But if you change the vehicle.h file, so if you put the definitions in here and you're editing them a bunch, then when you change this vehicle.h, you're changing the main.cpp and the vehicle.cpp because it's included vehicle.h. So to answer your questions, do the definitions go in the H, the CPP, the CPP? But you technically don't have to. Like we're not, when it comes to labs, we're not grading you on, are you doing everything exactly like you should be doing? We're only grading you on, does it work properly? So you could put the definitions in the H file if you wanted to. I personally wouldn't, but if you just went like, if you went like that, you could do this and then start putting definitions in here if you wanted to, if that makes more sense to you. Same thing in the Visual Studio. Yeah, you'll learn that C++ allows you to do a lot of things. It does not limit you to do things unless it will, no matter, like unless there's no way to stop you from having a compilation error, like if there's no way it can like figure itself out, it will allow you to do things, even if it like really shouldn't do it. Okay. So back to, or I guess that was a question from the lab. So now going on to the quiz study guide. So yeah, assuming you've gotten your lesson from Fox, I'm going to be talking about pointers, and especially after going through pointers and references, I'm going to do a little spiel that I have about pointers and explain them in the way that makes sense to me. If the way that Fox has talked about them makes sense to you, which it does for a lot of people like Fox, I would recommend listening to my spiel as just a way to confirm what your understanding of it is. Don't try to use it as a new way to understand the pointers and references. If you don't understand it, hopefully it might be able to help you in some way. But it's really just what helped me, and I didn't take this with Fox, and I prefer my way at this point. But both of them are valid. Well, Fox's is probably more valid just because he's a teacher, but my way has never let me down. So it all is still just pointers. Mine's just a certain way to think about it. Okay, so just going through pointers now. Let's shrink that. I'm gonna put you down here, and that down here. And we're gonna go into main, and we're gonna work down here. Shrink that. Shrink that. Okay, what is a pointer? The strict, what is a pointer in C++? We can make an integer pointer and then call it var1 equals new int 1. So this is an integer pointer. It is a pointer. This is the way you tell if something's a pointer is if it's got its star in this definition. that points to an address that stores an integer with the value of 1. So the variable itself does not store a value of 1. The variable itself stores an address. At that address, though, is a value of 1, what is actually at that address in memory. The way we could get to that address, I guess this is technically later, but if you did cout var1, and I'm actually going to put all this stuff in front of it inside a comment. The way you get to this is not by doing this output statement. It's by doing this output statement. And the second output statement, I think, it showcases one of the more complex topics of pointers, just because this symbol right here, and it's also going to be important with the ampersand, it's used in two different contexts that do two very different things. One of them in initialization and one of them in actual usage. But even though they're two completely different things in usage, they both are related to pointers, so that can get really confusing for people. I know it did for me. So if I run this, you'll see that the first one, this first var1, oh, here we go. This first var1, when you just print it out, prints out some random thing like this. And this random thing is a hex value. So if you remember from programming 1, hex values, they can store numbers from 0 to F. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So it's a hex value that is an address in memory. But then when we did the star before the variable name, that's what got us the actual value at that memory. Now let's add another level to this. What if we just did int, I'm gonna call this var2, even though it's a weird order, don't at me. Here, actually I'm gonna call this value, and this one PTR. So here, this is PTR, and here, that's that. Yes, 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 why is this bad? PTR is defined right there, shut up. Oh, I don't have a semicolon here, okay. So value, I'm gonna say value equals 5. And then right here, I'm gonna set it equal to value. Now, this doesn't work. And it's mad because value itself is an integer. It's not an address. To get the address of a variable, you put an ampersand in front of it. So there you go. This is the first time we're seeing ampersand. If you've watched his lectures, you know that there's another, and it'll be coming up in a bit. But to get the address of something, you put a little ampersand there. So in our case, I'm going to do cout value endl cout ampersand value endl. So with all of this, when we run it, you'll see value is 5. The address of value is this thing right here, 001EFA98. And then the value of pointer is the same thing as the address of value. And then a dereferencing pointer to go to what's at that memory location is this 5. So they're directly connected. It isn't some magical, mystical pointer land. They are this, and these are just values. The thing that I want to make you understand by this is that pointers are just a variable. They're like, the thing that really makes sense to me is that pointers aren't some magical in computer thing that's kept track of in some abstract way. It is just a variable. It is just a variable that is it's a hexadecimal number. That's true for all pointers. The only thing weird about them is their initialization is a little weird, and then getting the ampersand and star to go between them, like to manipulate the pointers themselves. But pointers are just variables. There's nothing crazy about than that. Okay, so actually going back to the study guide, I know I just started with what is a pointer. Why I use pointers? Pointers are super useful to store. If you're storing the memory address in a bunch of places, then you still only have one object. So if you change any of those, if you go to the address, if you dereference any of those pointers and go to that same address and change it, it's changing it for all of it. So one of the uses is for having the same thing in multiple places. That is, when you change it one way, it's changed for all of them. Sometimes this is exactly what you want. Sometimes that's not at all what you want. So you really just have to think about what situation. Another useful thing is that if your data is really large, like if your variable is storing a file and that file has like a billion entries or trillion, however many entries you want to talk about, at some point that's just so much information. If you tried to copy that into another place, then that would be a big issue to just copy, like doing all the operations to copy that. So using pointers, you can instead just copy the address. And that way you don't have to do all those calculations to make the actual full copy. But then you have to be careful with the original thing I said. If you make a change to what it's at that address, it changes it for the other one. So you might want to make all of your stuff read only if you want to be worried about that. So yeah, the big thing is accessing the same information in multiple places, and then the other big thing is only have to have one copy of that information if it's a lot of information. What does the declaration of the pointer look like? It's the same thing as any other declaration except it has a star. So the declaration's always just like the int val, like that. So you could have anything as int and anything as val. So anything as int as long as it's a data type, primitive or custom made. And then anything as variable name, that's like just anything that's a legal variable. And then putting a star. Once the star is there, it becomes a pointer instead of the actual value. That's just the declaration. For how do you assign a pointer, that gets a little trickier. If you don't want to assign it to a value that already exists, so like right here, if we did something like this, we could always do, like if you do int val and then val pointer, you could initialize it where whatever the default value of val is, that one you can initialize like any other way, val. Then to initialize the pointer to that value, just do address of val, just like we did down here. This would store the information on the stack, and we'll get to stack and heap memory and dynamic memory later. The other way to do it is through without having this intermediary value and using the new keyword. And so you use the new keyword and then you put a constructor. So this is actually the standard construct. I don't know, could I just put one? No, yeah. So you need to manually call the constructor like that. So here you do new and then you call a constructor. So for vehicle, we could do a vehicle and then a new vehicle and just the default constructor. So just like that. So the star and that new keyword. And so this is where I'm talking about the new keyword from last time. It creates a pointer. And so this is creating a pointer to memory that's on the heap. So there's nothing on the stack anymore. But the pointer itself, pointers themselves are always on the stack. So like I said, pointers are just variables. Pointers are just variables and they store a memory address. The variable, and thus it's storing the memory address, is on the stack. But the thing that it's pointing to, where the actual memory is, where like it's storing numbers that represent of address, but where that address actually is on the heap when you set it up like this. The other way, when we set up like this, int value 5 is on the stack, and so therefore its address is also on the stack. So this is all on the stack. The pointer's on the stack and the memory address it's pointing to is on the stack. But here, the pointer's on the stack and the memory that it's pointing to is on the heap. So I'm saying that now, and I know I said I was going to talk about stacks and heap later, but we'll come back to that concept. But I'm just saying it now. How do you assign or reassign a pointer? So you just set it equal to another pointer or another memory address. So with here, if we were just working with ints, new int 1. So if we've got all of this right now, if we wanted to reassign val pointer, we just have to set it equal to a memory address or another pointer, because pointers store memory addresses. So val pointer, we could set it equal to pointer, or val, there we go. Pointer, we could set it equal to the address of val, of value. There we go. So as long as you set it equal to another pointer of the same type, it has to be an int pointer. There's a difference between an int pointer and a vehicle pointer. Conceptually, they still just store memory addresses, but the compiler knows the difference between a memory address that's storing an int and a memory address that's storing a vehicle or something. But as long as it's set equal to another pointer of the same type or an address that's storing memory of the same type, you're totally good. So let's see, reassign. What is a pointer initialized to? Well, let's look at it. I think it's just uninitialized. If we did that, what is that gonna do? I really don't know. Oh, yeah, it's bad. So uninitialized local variable pointer. So again, they don't get initialized to anything. They're like primitives. I wonder if vehicle. I don't think vehicle gets initialized to anything either, because again, this isn't a vehicle object. It is a vehicle pointer. So the pointer itself isn't. Yeah, it's still not initialized. Oh, I'm trying to see out. So I can't even do that. Let's just get rid of that. See what that yells at us about. Yeah, so it doesn't initialize to anything. So since it's not initializing an object, because objects get initialized to a default value, it's initializing a memory address. It doesn't do that. Memory addresses don't have that default value, just like primitives. So it doesn't have a default. Let's back up to what we had before, because that was more useful for what we're talking about. We're fine now. Yeah, no, it's only mad from before. Yeah, we're fine. Okay. What is null pointer? So null pointer. Oh, I'm leaning back now. See that? Null pointer is explicitly saying this thing is now storing. This pointer is now pointing to nothing. So there's a keyword called delete, which I'm shocked it's not talked about here. How does it mean to dereference a pointer? Do we talk about delete or anything on here? We don't. That's whack. I wonder if it's in the quiz. Anyways, there's a way to delete a pointer, and we're going to talk about that with just this. So if we see out val pointer, and if we do the same thing, it's end L, my B. Different. So if we do this, we've seen this before, that outputs the address and then 1. Super straightforward. But what we can do is delete val pointer. And so there's 2 words for delete, but since we're not getting into that right now, I'm not going to. But deleting val pointer, when you do this, val pointer still stores the same number. So doing this does not stop val pointer from storing that same memory address. What it does is, since this is pointing to address on the heap, it deallocates that. So this is going to be an issue now. Let's see what this does. Oh, it even threw an error. Like we're not supposed to have access to that information anymore because we deleted it. So here, let me, instead of doing that, let's put this right there. So if we run it like this. Oh, it's not pointing to the same thing. I just lied to you guys. I try not to do that, but you know, I also run code to show you things so that even if I do lie to you, I get called out by my own code. So deleting it does change the memory address, but it's not 0. Okay, so my point is that this isn't a thing anymore, but then if we do, what do I want? I want to show you the whole thing so I stop looking like a numbnut. That's crazy. There we go. Stop that, run it. There we go. This is what I wanted to show you, and this makes me not look like a crazy person. There was a hint of truth in what I was trying to tell you. So initially, we had val pointer set to 1. I want to be able to see it as well. Move that out of the way. Okay, so initially, there's something in my mask. Initially, we had val pointer set to 1 on the heap, this new int 1. So that was storing a memory address on the heap, and at that memory address, it was storing 1. So we could print out val pointer and what val pointer is pointing to by dereferencing it. And that got us 011611308 and 1. Okay, give me a second. Sorry, mask issues. Anyways, so yes, we first initialize it. It was storing a memory address on the heap, and that memory address was storing 1, so we could print out val pointer and print out the dereference val pointer, and both of those are legitimate values. When you delete val pointer, that's what gave us the error before when we tried to do cout dereference val pointer. This was an error. So even though it's not a compiler error, it's a runtime error because we were accessing invalid memory. But val pointer is still something valid we can print out so we can see what memory address it's pointing to now, which is this 00008123. But trying to do it is said that's in accessible memory, but it's still technically storing something. So doing val pointer equals null pointer and printing that out, that's what gets us the 00 value. So that's explicitly saying this is no longer pointing to anything. I wonder if we could do dereference val pointer. I think it's gonna be mad at us because we're not allowed to access that memory. Could I have existence, please? Thank you. But I want it a little bit bigger. There we go. Oh yeah, that's a no-no. Yeah, that's that. So that's still a no-no. Trying to do something with it's a no-no. Stop. So yeah, you can't do either of those things. But that's just showing the explicit nature of setting it equal to null pointer. That is explicitly saying we expect this to point to nothing. We're setting it equal to nothing, and that's standard practice. It's not an error to not put that. Like you can see, it's not actually an error. So everything can still run fine like this. But if we try to dereference val pointer and do something to that after deleting it, then it'd be an issue. You can Going all the way back, setting the number. Yes. You can still do val pointer and set it equal to something new. So new int 10. And then we could see out. You can still use it after the fact, but then you need to change what val pointer is. You can't do it by changing what val pointer points to. So you still can do that. It's just once you delete it, you no longer can access the memory it's pointing to. And then setting it to null pointer is explicitly saying set this equal to 0. Like this is something we're explicitly not using. So it's standard practice to do that. Okay, so going through all of that, after that, that was all for, what was that all for? Null pointer, okay. Dereferencing, what does it mean to dereference? I've been saying that a lot, so sorry if I hadn't explained that yet. But dereferencing a pointer is saying, go to the data that this memory address is storing. So dereferencing a pointer, we're saying like that's what putting a star in front of the pointer right here is. That's saying go to the value that this thing is pointing to. You can actually make a double pointer, so I'm going to get rid of a lot of this. You can make a pointer to a pointer. You can make int star star val pointer because that's a great name, and to say it's equal to the address of val pointer. There we go. And so now, since this is a pointer to a pointer, to get to that value, you actually have to dereference it twice. So if you couted val pointer, cout 1 dereference, all that, it gives different values for each of them, but it's a pointer to a pointer. But so dereferencing is just putting a star in front, and that goes to what the memory address is storing. You can also technically dereference anything, but the compiler will be mad at you. So if we did a third one, even though it's just a pointer to a pointer, C++ gets mad at you because like, hey, you're using extra star to something that's not a pointer. But if you explicitly, you can brute force this one by saying int pointer. So if we are saying this is an int pointer and doing this, it's gonna, I think it's just gonna print out 1, but let's look. I don't think that's not what I want. Oh, yes, it is. Oh, it threw an error. Yeah, you're not supposed to read the address that's stored at 1. Fun fact, you really should never, ever do that. I don't know if there's a way to like brute force even through this exception to do that, but getting into that low of an address would like start fucking with your kernel. The zero address is explicitly null pointer, so that's why you're allowed to set it equal to that, but you still can access it. But yeah, you're not supposed to get access to 1, but you can see there, I dereferenced it and it's the address of 1. That's what's yelling at me right here. That's what this value is. So dereferencing is just putting the star in front. What is the membership operator and the indirect membership operator? What? Oh, hold up, what? Oh. Okay. So if I made a vehicle pointer, let's get rid of all this. If I made a vehicle pointer, var, sure. And then a non-vehicle pointer, yeah, let's make a non-vehicle one. Oh, there, one. There we go. So if I had this, you'll notice that if I do var1 and then put a dot, I get access to get price, display, get price, vehicle, year, make, model. So I'm just going to do display. Now, if I do var2 and do dot, I still get access to these things, but let's look at what happens when I try to do that. It auto-completes this for me. So this dash arrow is the membership operator. If I tried to force it to be a dot, you'll see that this is an error. So if you weren't working in an IDE, that would be an error. But since I'm in an IDE and I put dot, it understands that most of the time when someone's putting dot, they're meaning to get access to these member functions. So instead, you have to do dash arrow. So if you weren't working in IDE, like if you were working in Zybooks, you'd have to manually put this dash arrow, but since I'm in an IDE, it auto-completes that. But it's all because it's a pointer. What this pointer is doing, what this dash arrow is doing, you could explicitly do that by doing dereference inside of brackets, so you're only dereferencing that pointer and not the whole thing. So that dash arrow is a shorthand for this whole setup right here. And it makes it easier to write that because it's only 2 things instead of 4, and it's also all right after the variable instead of some stuff before, so you don't have to plan ahead. But so this is the same as var2 dash arrow display. Because remember, a pointer is just a memory address. A memory address does not have access to, so var2.display dot. A memory address does not have access to this display function. A memory address is just a memory address. So we have to go to the memory address to get access to the vehicle object, and then the vehicle object has access to the display function. And this membership operator does that. What's the indirect membership operator? What the fuck? I've probably heard the name of it. I just don't remember the name of it. I've never tested on that. So maybe this is the indirect way to do it, and this is the direct way to do it. He probably has it in his, he probably talked about it in his lecture or something, so I'd recommend watching a lecture for that. Sorry, I don't know the exact definition between those two, but that's an important thing to understand. Okay, so we just talked a lot about pointers. I'm going to go through my reference stuff before I do my mini lecture on shenanigans, but any questions about that? Okay, cool. So now on to references. References are a little simpler. They're basically a way to use pointers without any of the pointer syntax. There we go. So what is a reference? A reference is, so let's say we have int x equals 2. Then you can have int ampersand y equals x. So like I said, we were going to see this ampersand one more time. Here's that second time. It's in this context, and this is how you create a reference. And what a reference is now y and x are the same thing. If I change something to y, it's going to change something to x. If I even made a pointer to x, if I did int star z equals the address of x, and I change z, if I dereference z and change it, it's going to change y. And if I change y, it's going to change what z points to. So see it's in action. If we see out x, let's do the same thing. we see out y. And then, so we're going to do this a lot. So I'm just going to copy and paste this. They do both have the same memory address. That is a great question. Let's put a little printout statement right here. And that's actually where my explanation for it when I get into my little graphic. Oh, other way around. They do have the same memory address. Stop. So if we do that, look at that. Both of them print out 2. Both of them have that same memory address. And so that's actually where, Gabby, that is a great question. That is actually where, like, why changing one changes the other. Because doing it like this is just something that is for us. That's a reference is saying now when we write y, we're actually writing x. So that's really just for our visual. And it makes it the same. It's storing it at the same address. And it's actually not just for our visual because you can pass by reference, and that's super important. But it's making them the same address. So changing one changes that address, and that changes the other. That's how it works. So yes, great question there. It's the same address. And so yeah, just showing that if I did dereference z equals 10, and I printed out this again, you'll see that I changed what z is pointing to, which was x, and so that's changing x, which also changes y. So just any changes to x changes y, and changes to y changes x, and it's because they are the same thing. And they have the same address, they store the same value, and it's just the same thing. What does declaration for a reference looks like? It looks like that. It's got this ampersand right here. Again, this ampersand is a completely different use from this one, and so we'll get into that. But yeah, that's what declaration looks like. Also, it cannot. This is a cannot. In C++, there's not a lot of cannots, but this cannot look like this. I know with integers, so if we did like another one, int a ampersand, if you did this, it just wouldn't have a default value, but you could still do it and then initialize it later. References, you cannot. That is a hard no, because they have to be set equal to something. They have to be. They're like the whole concept of reference is that they're equal to something. They can't be set equal to something later. You could even do it set equal to a. So now both of these aren't initialized technically. Well, y is an initialized reference, but the actual value isn't initialized. So it has to be connected to a variable. There's no default variable. There's no unknown default variable. It has to be given a variable, and it has to be of the same type. The advantages and disadvantages of pointers versus references. Okay, so this one, I think in his lectures, he probably puts it like at the very end. It's like a compare contrast. But just off of me, what my opinions, which is what labs are all about, so it might not be 100% like Fox's lecture. Both of them are really good at storing memory in a way that you have access to the exact same thing in multiple places, so you don't have to copy all that information. Because references are a lot like pointers in the back end, so they still have that advantage. What the disadvantage and advantage between the two of them comes down to actual usage of them. So both, when I was originally talking like why would you use a pointer? When I was talking about like sharing that, like copying large information or having the same information in multiple places, both of those pointers and references are good for. Actually, references are probably are probably worse at having it in multiple places. Yeah, because that'd be like storing. Yeah, but the disadvantage and advantage comes from their usage and syntax. So references, They're really useful because you don't have to do any of the pointer syntax to them. So you can just see out y, and that cout's the value. You can just do y dot to get access to member functions or member variables. It's references are pointers without any of the syntactical requirements of a pointer. The disadvantage comes from that pointers can be used in more ways because they have the extra syntax and don't have to be initialized and are more like fundamental in a way. You can have like an array. Excuse me, oh my goodness. You can have like an array of pointers or a vector of pointers. You can't have a vector of references. That's not a thing. You can't do vector int ampersand. Oh my god, can you? Holy crap. Well, you couldn't do, hold on. There's something you can't do with this. That has to be illegal, doesn't it? Oh, there we go. Okay, thank you. Yeah, you can't do this. Can I even do this? Okay, thank God. I'm not crazy. It's just not a compiler. Yeah, you can't have a vector of pointers. You can't have an array of pointers. I thought I was lying to you again. I don't like to lie too often, and twice in one lab is just woo. Okay. So yeah, you're getting all this errors because it was a vector of references, which you can't do. So yeah, if it wasn't a reference, you'd be fine. It's because a vector is just an array in the back end, and arrays with multiple values sometimes are initialized to things. Like that's the big thing, is that there's stuff that's not initialized, and it all comes back to you can't do int ampersand y semicolon. The fact that you can't do that, that's what leads back to all the uses where you can't use references, but you can use pointers. That's the big thing. But yeah, references are usually preferred just because then you don't have to deal with pointers. So if you never have to do this, usually it's better, and that'll come into passing by references and passing by pointers, which we'll get into a little later. If no one has any questions, I'm gonna go to the bathroom. When I come back, I'm doing my mini lesson. But yeah, does anyone have any questions? Oh my god, why do I still have that aromatic? Okay, so yes, I'm gonna go to the bathroom. So take this time to take like a little bit of a break. We've been going for an hour, so just rest for a second. I'll be back. We'll keep going. I'm mostly gonna stop. I don't need to pause it. Yeah, that's, or can I pause recording? Unpause. We are back. Hello. So yes. Share my screen, share, hello, shrink that. Okay, so poisoned references, yes, we just went through all that. We talked about like the syntax between pointer and references, and then we had like the ampersand versus star. So first, before I hop into like drawing out some stuff, I'm gonna do int. I'm gonna say a equals 1, int star b equals address of a. It could also be int star c equals new int 3 int star d equals b int ampersand E equals A. Okay. So this is like all the different ways I can think of to initialize. Oh, and you can also do int, do Z. And then in here, we're gonna do int do 0. Sure. This is all the different ways I can think of to legally initialize any of these values. So you can initialize an integer without, you can declare an integer without initialization. That's not illegal, you just couldn't use it after the fact. But then you could initialize a with a value, and that's totally fine. Oh, this should be int star. You can declare a pointer without initializing it. You can declare it these separate ways by doing the address of a declared variable of the same type, using the new keyword to allocate on the heap, or setting it equal to another pointer. And then references only have the one way to do it. So that's, again, there's not as much flexibility with references like we talked about before. And then you'll see this is one use of that star, and here's the other. And this is in the context of initialization, of declaration. The other way to use the star and ampersand is outside of it, and they have nothing to do with references. So we're just gonna references, it is used once there and never again. But with pointers, the star and ampersand are used to move either to a memory address or to get the memory address of a value. So to get memory address, you can get the memory address of any variable. So any one of these, I guess, so technically ampersand can be useful on E, but that's just like it can be useful on Z. So for a reference, ampersand and star have all the uses that they do for a non-pointer or non-reference. With the first chunk, could you go over what each of their outputs would be? Yeah, sure. So for the output of Z, that'd be illegal. So and out, like you wouldn't be allowed to do that. Or I guess usually it yells. A would be fine. That'd be just the number one. Yeah, here I'll go over it and then do one by one if it needs to. This I think should be mad at me. I'm shocked that it's not. Oh yeah, it's being mad at me right there. Look at that. Uninitialized local variable Z. So you couldn't do that. A would output 1. B 0, you couldn't do that. Uninitialized. B ampersand A would be the address of A. So if you did B or if you did C out address of A, those would both be the same thing. And then on that same note, C outing D would be the same thing. So yeah, address of A, B, and D are all going to output the same value. C would be its own separate thing. Even if it was like this, even if it pointed to the same value, C would be its own separate thing. So the address does not dictate what the value is, but so that's the C is different. And then E would output the same thing as A. So if we did address of E, so address of E would, there's a lot of things here that would be the same thing. Address of E would be the same thing as all the above. And also E and A would output the same thing. So here, so all of those are the same thing. And then also go in the opposite direction. So if instead of getting the address of A and the address of E, if we dereferenced everything, and actually I wonder, I think would it be mad if I did that? So yeah, so this is what we had before, just dereferenced. All of those would output the same thing. All of that would output 1. But then when you dereference, getting the address of something and then dereferencing it would just be the same thing as outputting itself. So we could just do that. So Gabby, does that answer your question about like what each of these would output? Yeah, perfect. Okay. That kind of also goes over the concept of dereferencing and dereferencing and getting the address of stuff. So yeah. So this is all printing out the same stuff. This is all printing out the same stuff. And then this is all printing out the same stuff. So using the ampersand and using the asterisks when you're not initializing anymore just moves back and forth between the address and what it's pointing to. And like we showed with double pointers, you can move back twice or you can dereference twice if it's allowed. You couldn't just randomly do it here. Like I said, unless you forcibly did it, but then it would throw an error because B is, when you dereference B, it's pointing to 1. And so if you force that to be a pointer and then dereference it, you'd be accessing what's at the address of 1, which would not be allowed. So that's actually really great. And then one other concept is that you can do ampersand B, and that's, since it's getting access to that address, you can now also change that. So this does change it. So if we did that, and then let's add a little star for them. We did that there. That does change all of them. So now they're all 10. So understand that by doing that to pointers, you are actually changing the value. With that, let's share a little whiteboard. Oh God. Okay, I need to move around. Shit. Okay, so in this class, you are going to get a fair bit of questions that are just like, hey, given this code statement, figure out what the hell this value is. And so you're going to have to answer those questions. It's going to be like a whole long snippet, and you're going to have to keep track of everything and figure out a value. The way that I do those questions is by drawing a little table. This table has 3 rows. It has the address, the variable name, and then the value. So let's say we had code that was like int x equals 2, int pointer y equals address of x, and then dereference y equals 5. So going through this, what I would do is when int x equals 2, so anytime something's declared or anytime something's declared, I would add it to here. So I would do the variable is x. The address I represent as some sort of like symbol. Sorry, it's like a circle or a square, a triangle, or multiple of them. Anything that makes sure something shown is different. So in this case, I'm going to do a circle. And here, actually, let me change colors. Because I want to look pretty. Okay, here we go. Draw line. Yes, okay. So variable x with an address of 0. Because you're never, if we initialize something, we're never going to ask you to tell us what the numerical value of the address is. Like you can't know that unless you see out it in like an IDE and run it. We might tell you though, like here, I'll just get to the end. Okay, so with this right here, we did this and then the equals 2. And then y is initialized like that. So we do y square, and it holds a 0, this circle. So maybe circle's not the best because it kind of looks like 0. It doesn't hold 0. Say triangle. There we go. So then from this, we say dereference y equals 5. So you say y, it has this value. Dereferencing it goes to the address. I don't know if you can see here. Let me y, dereference it, goes to the value, and then change that to 5. So now this gets changed to 5. And so obviously this is a very simplistic example, but it's helpful to keep track of all this information. And then we could ask you, like, what is the value stored in y? The value stored in y is this triangle, and what this triangle represents is the address of x. So if you asked what's stored in y, the address of x, or a pointer pointing to x, or something like that. Don't say 5. That's the big thing. It's not 5. 5 is what's stored in x. So if we asked you what is the value of x, that would be 5. But we're here, this is this triangle. And triangle represents something. So what does triangle represent? It's not 5, it's the address of x or something along those lines. Wait, why isn't x 2? Because we changed it right here. So walking through that again. We did the first line that did this, the second line did that. But then when we got to the third line, we dereferenced y. So y stores this value. So dereferencing it goes to that address to here. And then we said, set that equal to 5. And so that changed this to 5. And so it'd be the same thing, like we actually wrote this in code. Oh, shit. If we wrote this in code and then after it did cout x, we would be couting, that would result in 5. So we could even do that. We could do that right now. Share. This is going to get rid of the whiteboard, isn't it? That's so sad. Do the same thing in x equals 2. In star y equals the address of x. And then dereference y equals 5. So maybe I'll do 7 just so you can, something that's not 9. Something that looks, so 5 and 2 look a little similar. And then cout x. X would have the value of 9. Does that make sense, Gabby? Because we're going to the address that y stores and changing what's there. And so that little table that I had, this little table view, oh, it's saved, nice. This little table view is all just to keep track of all this information, and you go through it line by line, changing it. So you're not, don't try to keep in your head. And sometimes people represent it with just like int x equals 5, and then or 2, whatever, int x equals 5, and then int y equals address of x. And then when they get to this line, like they do all the initializations, right? Like that's usually pretty easy, but it's when you start changing stuff, sometimes they don't keep track of everything that's changed. How this would be useful for references. Let's erase all this. So let's say we did, I'm gonna draw it over here. Let's say we had int x equals, I gotta move this. Also gonna move that. There we go. Int x equals, again, let's say 1. I'm not gonna add semicolons. That's not gonna turn out pretty. So if we did int x equals 1, and then int reference z equals x, and then int pointer y equals address of z, sure. And then we did not int anymore. And then we said z equals 10. Oh God, why did I just add a 0 to a 1? Let's say that equals 8, sure. So we did all this. Some might ask like, if you ask what's stored at x, what's stored at z, what's stored at, what's stored at x or what's stored at z, one of them might be like the value of the other one or something like that. So like what's stored at z, some could say the value of x, or what's stored at x, the value of z. Those could be correct answers. What's stored in y, one of the correct answers might be the value of x. So like this might all this stuff might just be, even though there's stuff after int star y equals x, like let's say we then do y star equals 23. So if we did that or something, it could all bounce back to something that's important here. And so, but in this case, if you drew it out, you did x and then 0 and then 1 and then z. Oh, the way you do this, you write the same address. So there, and so since it's the same address, it stores the same value. And then here y is the address of z, so it's a 0. I give it that own address. Oh my God, why did I pick, whatever, I'm just gonna stick with it. And then you did z equals 8. So z equals 8. But since it's at that address, you also have to change this one, since it's the same address. So maybe an easier way to represent it would be, instead of x, you could do, instead of having like a separate thing, you could have x slash z, something like that, to add it so this shows that they're the same place. And so just you have to change it once if that's better for you. I personally just keep multiple, and if it's the same address, you change the same thing. And then star y equals 23. So you go to y, dereference it to this address, undo, let's change that to orange. Same address, and change that to 23. And so now with this, any questions you get, the information's all right there, so you won't have to jump back if it's not something about like the last line. If it's something like what does y store, it's the address of x or the address of z. Both of those are valid. So just to keep track of information, this is how I do this for any of those questions. And it hasn't ever failed me yet. So it hasn't failed me because this is the correct way to think about it. I think this is how it works with that whole address and value and stuff. It's not, there's multiple ways to, it's just a correct way to think about it. Like all this stuff is valid logic. You can think about it however you want, as long as it keeps track of like everything with the addresses and going to the address to change stuff, and how references work by being the exact same thing as x. Okay, so that's that. That's what I want to talk about there. This is like a practical use for this class, just like if people ask questions on a test, you don't have access to a compiler to actually run everything and check. Because in real life, I don't ever use this table. Oh, can you see my whole screen anymore? Probably not. There we go. In real life, you don't have access. In real life, you have access to a compiler, so you can easily just like check what it is. When people come to me with questions, usually I say like test it or try it, if they come to me like a hypothetical. But in an exam, you don't have access to that. So this is that technique is really good for taking tests and stuff, because then it's easy to keep track of stuff. Share screen. Closing the whiteboard just cuts it out. Cool. Okay. So with that, I think we're near the end of this documentation. Yeah, it's only a couple other things. What is passing by reference versus passing by value? So this gets into using all of these concepts in functions. So let's write a function. I'm going to do int fun return, I need to drop that, return 0, sure. And this function takes a value. If we said x equals 2 here, And then down here, let's just do it all up here. I'll just get rid of all this. That's fine. If we had that set up and then did int x equals 5, fun x, cout x. What's 5 and 2's today? I don't really know. 10, sure. There we go. If we ran this, this is passing by copy. So since it's just a copy, what happens in there does not change what happens out here. However, now that we've covered that other stuff, we can now stop doing that. We can undo, not undo, but we can change how that works. If we pass by reference, is how you can think about it. I'm going to add a little comment here. Is for the function. Oh God, let's not call this x. Let's call this var. Sure. Var. Because I got x down there. So the way you can think about a parameter is like, let's right here. It's just int var equals whatever you passed in. So in our case, I'm going to put x. So you can think about it as an int var equals x. And in this case, var is separate from x. If you change var, it does not change x. You know that. But if we add an ampersand, that adds an ampersand right there. And so now it's int reference var equals x. And the reason, like we told you that you couldn't just do int ampersand var, like we told you couldn't just have that, but it works in a parameter because in a parameter, it doesn't actually exist until someone calls it. And once someone calls it, there has to be something in the parameters. So that's totally fine to do. So with this, when it's set up like here, if I change x, when I change var, it does actually change x. You see, it does actually set it equal to 2. So yeah, that's passing by reference. Passing by pointer is very similar conceptually, but again, references remove all the pointer syntax, so you don't need to worry about that anymore. But now that it is a pointer, this is an error. If we want it, we still want to send x into this function, but you can't send it by x anymore. You have to send it by its address of x. So now you can't do int star var equals x. That's not a thing. But you can do int star var equals the address of x. So that's what you can do to pass it into this function. And then again here, you can't just do var equals 2. You have to do dereference var equals 2. So that changes it. And that makes sense because since we're passing addresses, if we pass the address into here, this is going to the same address that this is dealing with. And references, again, also deal with addresses in the back end, but they make it so you don't have to deal with all the syntax. So we're passing instead of passing the value, we're passing the address into this function. And that's passing by pointers or passing by reference. So reference was with the ampersand, pointers with the star. And both of those now, if you do change the parameter, you're changing it out here too. Okay, awesome. Last little bit, what is the stack and the heap? So both of them are how memory is managed in a C++ program. The stack, anything stored on the stack has to have a specified value that won't change. What I mean by that is that an integer takes up 8 bytes, or 4, it might be 4. It's 4 bytes, yes. And that we'll get into that when we get into binary files. An integer is 4 bytes and it's always 4 bytes. So an integer can be on the stack. Same with character is 1 byte. Even a pointer, the pointer itself, like I said, is on the stack. A pointer is just a memory address, and all memory addresses are the same size, so it stores the same amount of information, all pointers. So pointers can be on the stack. Arrays, dynamic, well, technically, arrays can be on the stack if it's a guaranteed value. But sometimes at the same memory address, if you're storing like int x equals new, and we didn't even talk about arrays, did we? Oh, geez. Int let's get rid of this stuff. And that stuff. I didn't unpause the recording, did I? Oh no, I did. Oh, dope. Awesome. Okay. Did I do that wrong? New that. Oh, I need it. There we go. Int x equals new int. So arrays and pointers are technically the same thing, but the standard way to think about arrays is multiple pieces of information. So this would be multiple pieces of information. And here we'll put a value on there. So this array is storing 5 pieces of information. Now you can have an array on the stack if you do int star x equals int 5. You can do that, and you've seen this in Java. Oh, no, you can't. Why not? If I do manually type it out like this, 1. Oh, it's because, there we go. Stop being mad at me for doing dumb things with my variable names. Oh. Hello? What are you in here for?
This is Section Logic.
Yes. Is my lab over? My lab might be over. It is. No, that's 10. Oh, 2 minutes. Yeah. Okay, sure.
Section Logic here?
Just maybe next period.
What period is it now? What time is it?
10:24. So yeah, I've got like a minute left in this period.
Oh, 10:24. Okay. No. Oh, 10. Okay, but then at 10:40 my class is, yes?
That I don't know about. Sure.
Is it okay if I log in?
Just give me a second. If you want the computer, sure, but just give me a second to wrap up with my kids, okay?
Okay, so you're doing your Zoom lecture from here.
I am. Yeah, there could be students in here if they wanted to be, but they're all high flexing.
Okay.
So just give me a second. So lab is about wrapped up, everyone. I'm gonna get us off just so the next person can start setting up. But so stack and a heap, yeah, stack has to have a required amount, heap doesn't. And so using the new keyword, we can allocate random amounts of information on the heap. So that'd be like, here you could do 5, or actually you can even have a variable like int x equals 10. And so you could have a variable amount. Yeah. That is dynamic memory when you store stuff on the heap. And then what is the function of new and delete? We kind of covered that earlier. There's the delete. So we covered delete earlier. I do have to go to let the next person set up. I hope you guys have a good rest of your day. This post will be recorded on that channel. If you don't have that, feel free to DM me on Slack and I can help you out with that. Have a good rest of your day, everyone.
Thanks, man.
No problem.
You put it on Slack?
Slack.
What is Slack?
Do you use Microsoft Teams?
I don't.
Any sort of digital communication, like with groups of people, Discord?
Yeah, I use Listserv.
So a listserv, I would say, is a little limited just because it's only emails. This would be so that they can have communications in real-time aspects.